You know this sound? Not thunder, not a rocket, a GE-90. 115,000 pounds of thrust per engine. This is the Boeing 777, the twin that crossed oceans when everyone said you needed 4. It dethroned a queen, carried over 1 billion passengers, and set the gold standard for safety, while its own successor still waits in the wings. How did 2 engines conquer long haul and change aviation forever? Rewind to the 1980s. Long haul aviation looked different. 3 engines ruled the skies: the McDonnell Douglas DC-10, the Lockheed L-1011 TriStar. These trijets dominated intercontinental routes, not because they were elegant or efficient, but because regulators didn't trust twins. The logic was simple. If you lose 1 engine over the Pacific, you still have 2 left. Redundancy meant safety, and safety meant 3 engines minimum. Boeing had its jumbo, the 747, 4 engines, unmatched capacity. The queen of the skies, but it was too big and too expensive for most routes in a still developing world. Then, there was the 767 twin engines, efficient but too small for high-density markets and long-haul trunk routes. Airlines were stuck in the middle. They needed something that could carry 300 to 400 passengers across oceans without burning 747-level fuel. A Goldilocks jet. Not too big, not too small, just right. But here's the problem. Aviation regulators, including the FAA, had a rule: ETOPS, Extended Range Twin Engine Operational Performance Standards. It dictated how far a twin-engine aircraft could fly from the nearest airport. Early ETOPS limits were just 60 minutes. That meant twins could not fly further than 60 minutes without a diversion airport, banned from true ocean crossings. Then Boeing 767 began proving itself. Reliability improved. Engine failure rates dropped. By the late 1980s, ETOPS was extended to 120 minutes, then 180 minutes. Suddenly, twins could cross the Atlantic. The industry was shifting, and Boeing saw the opening. This wasn't just about building another jet. It was about changing how the world connected. October 1989, United Airlines walks into Boeing's offices with a problem. We need a jet that can fly 300 to 400 passengers across the Pacific. It needs to be more efficient than the 747, more capable than the 767, and it needs to be ready by the mid-1990s. Boeing's answer: we'll design it with you. This was revolutionary. Airlines had always told manufacturers what they wanted. But Boeing flipped the script. 8 airlines, United, All Nippon Airways, British Airways, Japan Airlines, Qantas, Cathay Pacific, American Airlines, and Delta were invited into the design process from day one, forming what Boeing called the Working Together Group. Want wider aisles? Let's talk about fuselage dimensions. Concerned about turnaround times? Let's optimize the cargo door placement. Worried about crew training costs? Let's make the cockpit similar to the 757 and 767. Every decision was collaborative. Every feature was debated. This wasn't Boeing building a jet and hoping airlines would buy it. This was airlines building their perfect jet with Boeing's engineers. The program started as the 767X, a stretch long-range 767. But the more Boeing and airlines talked, the clearer it became. A stretch 767 wouldn't cut it. They needed an all-new aircraft. So Boeing went all in. Clean sheet design, larger fuselage, more advanced systems, a twin-engine jet designed specifically to replace trijets, and perhaps even the 747. Then came the engineering breakthrough. Boeing made the 777 the first jetliner to be 100% digitally designed using 3-dimensional computer graphics through KAIA software. No physical mock-ups, no clay models. Everything existed in a digital environment first. Why did this matter? Because Boeing could test every component virtually. Hydraulic lines, wiring harnesses, engine mounts. If 2 parts clashed in the computer, they caught it before manufacturing. The 777 would be the most precisely engineered jet ever built. In October 1990, United Airlines placed an order for 34 aircraft with options for 34 more, the largest order in Boeing's history at the time. April 9, 1994, the first 777 rolled out of Boeing's Everett factory. Thousands of workers, hundreds of airline representatives, all eyes on this gleaming white twin. Boeing was betting its future. The message was clear. 4 engines aren't needed to fly long. 2 will do just fine. Music. The 777 wasn't just another widebody. It was a philosophical shift. Boeing had always been conservative with control systems, cables, pulleys, hydraulics, mechanical links between the pilot and the flight services, direct analog control. The 777 changed that. It became Boeing's first aircraft with full fly-by-wire controls. No cables, no mechanical linkage. The pilot's input went to computers. The computers decided how to move the control surfaces. Fly-by-wire wasn't new. Airbus had been using it. But for Boeing, this was a leap. It meant weight savings. It meant smoother handling. It meant the aircraft could optimize its own aerodynamics in real time. Then there were the engines. The General Electric GE90 was designed specifically for the 777, an initial thrust rating of 81,000 pounds force. The GE90 1115B variant would eventually produce 115,300 pounds of thrust per engine. During testing, it set a world record at 127,900 pounds of thrust. To put that into perspective, each engine on the 777-300ER produces more thrust than 3 of the 4 engines on the original 747-100 combined, and its test record exceeded the 747-100's total output. The fan diameter alone is 128 inches, wide enough to swallow an entire 737 fuselage. These weren't just engines. These were feats of thermodynamic engineering. But power alone doesn't make an aircraft successful. Efficiency does. Boeing used composite materials throughout the 777 structure. Carbon fiber reinforced plastics in the tail. Lightweight aluminium-lithium alloys in the fuselage. Every pound saved meant more range or more payload. Then there was the cabin. The 777's fuselage was wider than the 767's, wide enough for a 10 abreast economy layout, but most airlines went with 9 abreast to offer more comfort, wider aisles, larger overhead bins. Business travelers noticed the 777 didn't just fly farther, it flew better. Boeing also designed the cockpit with commonality in mind. Pilots certified on the 757 or 767 could transition to the 777 easily. Similar flight deck layout, similar procedures, similar muscle memory. For airlines, this was gold. Flexibility, efficiency, lower costs, but the biggest innovation was not visible. It was regulatory. The Boeing 77 became the first aircraft to obtain ETOPS 180 rating even before it entered service. That meant it could fly routes of up to 180 minutes from the nearest airport right out of the gate. No proving period, no gradual expansion, immediate global reach. Later variants would push even further. The 777-300ER achieved ETOPS 330 certification, and the 77-2000LR shares that same rating. That's 5.5 hours from the nearest one-way. At that point, the entire planet opened up. There was nowhere a 777 couldn't go. The industry's mindset flipped. 4 engines weren't safer, they were just more expensive. The 777 validated a future where twins ruled long haul, and Boeing had built it first. Building the aircraft was one thing, proving it could survive the real world was another. Boeing's test program was exhaustive. Engineers subjected the airframe to stress tests that would never happen in service. They bent the wings upward until they flexed 24 feet at the tips. They loaded the fuselage until it was ready to buckle. They tested hydraulic systems, electrical systems, environmental controls. Every component pushed beyond its operational limits. Why? Because Boeing had to prove the 777 was bulletproof. The first 777 made its maiden flight on June 12, 1994. Pilots reported near-perfect handling, smooth, responsive, stable. But the FAA and international regulators didn't care about smooth. They cared about safety. And for a twin-engine jet seeking immediate ETOPS 180 certification, the bar was higher than ever. Boeing ran a gauntlet of tests, engine-out takeoffs, single-engine landings, fire suppression trials, rejected takeoffs at maximum weight, emergency descents, system failures, worst-case scenarios stacked on top of each other. The 777 passed everything. Then came the real test, United Airlines operational trials. United put pre-elite 777s through their paces in actual airline conditions. Real passengers, real cargo, real weather, real schedules. The results, near flawless reliability. The kind of numbers that make airline operations managers smile. By the time the FAA granted certification, the 777 had proved itself to be one of the most thoroughly tested jets in history, and the safety record that followed backed it up. Over the next 3 decades, the 777 would achieve one of the lowest accident rates of any widebody aircraft. That's not luck, that's engineering. While Airbus was still arguing that 4 engines were inherently safer, the A340 marketing literally said 4 engines for long haul. Boeing had the data. Twins were just as safe and far more efficient. The trijet era was over. The 777 had killed it. June 1995. United Airlines puts the first trip 77-200 into commercial service, London Heathrow to Washington dollars, a Boeing twin crossing the Atlantic. The baseline trip 7,720 was a workhorse range of about 5,240 nautical miles. Capacity for up to 440 passengers, around 300 with 2 or 3 classes enough to handle transatlantic and transpacific routes. Airlines loved it. Passengers loved it. And Boeing's order book exploded. But Boeing didn't stop there. Airlines wanted more range. They wanted to open new city pairs without refueling stops. They wanted to fly from the US West Coast directly to Southeast Asia. Enter the TRIP 7200ER. Extended range, bigger fuel tanks, reinforced landing gear for higher takeoff weights, upgraded engines. Range jumped to 7,065 nautical miles. Now you could fly from Los Angeles to Sydney, Los Angeles to London, Paris to Tokyo. Routes that previously required a stop or a 747 could now be flown by a more efficient twin. The 200ER became the backbone of long-haul operations for British Airways, Cathay Pacific, and all Nippon Airways. It opened markets. It enabled growth. It made long-haul aviation accessible to airlines that couldn't fill a 747. And here's the key. The 777 wasn't just replacing trijets. It was replacing 747s on routes where capacity didn't justify a jumbo, but range still mattered. Boeing was eating into its own 747 sales, but it didn't care because every 777 sold was more profitable than a 747, and it kept Airbus from stealing market share. Launch customers like United, British Airways, and Cathay Pacific became evangelists. They showcased the 777's reliability. They published performance data. They proved to other airlines that this twin could do what 4 engines used to do. Orders poured in from Asia, Europe, and the Middle East. The 777 was becoming a global standard, and Boeing had barely scratched the surface of what the platform could do. The trijet era wasn't just ending, it was collapsing. The economics were undeniable. Why fly 3 engines when 2 will do? Boeing had its hit, but the best was yet to come. The 777-200 and 200ER proved the concept. Now Boeing could stretch the platform. First came the 777-300. A simple idea, make it longer. The fuselage stretched by 33 feet. Capacity jumped to over 550 passengers at its exit limit. It was designed for high-traffic, shorter-range routes where airlines needed capacity but not extreme range. The 300 became a hit in Asia-Pacific markets. Japan Airlines, All Nippon Airways, Singapore Airlines, Cathay Pacific. Airlines operating dense regional routes loved it. Tokyo to Osaka, Hong Kong to Bangkok, Shanghai to Seoul. Routes that saw massive passenger volumes but didn't need the 7,300 nautical mile range. The 777-300 gave airlines a 747 alternative without the 4-engine operating costs. It was the right jet at the right time, but Boeing still had a problem. Ultra-long-haul routes. The 16-hour marathons still required 747s or the Airbus A340-500. Airlines wanted a twin that could fly anywhere, literally anywhere. Boeing's answer, the 777-2000LR, longer range, also called the Worldliner. This jet was a monster, maximum range of 8,555 nautical miles. That's enough to fly from New York to Singapore, Los Angeles to Dubai, London to Perth non-stop. The Trip 77-2000 LR was among the first aircraft to achieve ETOPS 330 certification. It could fly more than 5 hours from the nearest airport, which meant there was literally no point on Earth it couldn't reach. The 200 LR proved a point. With enough fuel and efficient engines, a twin could outlast and outrange anything with 4 engines. Then there was the Trip 7F, the freighter. Boeing took the 200 LR's airframe, removed the passenger windows, reinforced the floor, and added a massive cargo door range of 4,900 nautical miles with a full payload. The Trip 7F became the workhorse of modern air cargo. FedEx, Emirates, Sky Cargo, Qatar Airways Cargo, and Lufthansa Cargo. They all bought fleets. It replaced aging freighters, and it did it more efficiently. But Boeing saved the best for last. The Trip 7300ER extended range. This wasn't just another variant. This was the ultimate evolution of the entire platform. The longer fuselage of the 300, the massive fuel capacity of the 200 LR, powered exclusively by GE 9115B engines producing 115,000 pounds of thrust each. Rayed wingtips for better fuel efficiency. Reinforced structure for higher takeoff weights. The Trip 7300ER could carry 392 passengers in a typical 2-class layout. It could fly 7,370 nautical miles. That's Dubai to Los Angeles, Sydney to Dallas non-stop. And it did it at a profit. The 300ER gave airlines the capacity of a 747 with the operating costs of a Quinn. It was the Goldilocks jet perfected. Not too big, not too small, just right. Airlines realized something. They didn't need jumbos anymore. The Trip 7300ER wasn't just another variant. It was the 747's successor. Music. If there's one variant that defined the Trip 7's legacy, it's the 300ER. Airlines didn't just buy it, they built their entire long-haul networks around it. Emirates is the defining example. The airline that turned the Trip 77300ER into an icon. Emirates operates over 119 of them, more than any other airline in the world. It also flies them from everywhere. Dubai to New York, Dubai to Los Angeles, Dubai to Sydney, Dubai to Sao Paulo. 6 continents, 7-hour flights, 16-hour marathons. The 300ER does it all. Why? Because the economics work. But it wasn't just Emirates. Qatar Airways, Singapore Airlines, Air France, British Airways, Cathay Pacific, ANA. Every major long-haul carrier bought fleets of 300ERs. The aircraft became synonymous with premium travel. Qatar Airways debuted its Q-Suite business class product on the Trip 7300ER. Cathay Pacific upgraded its cabins. Singapore Airlines featured it on flagship routes. The Trip 7300ER wasn't just a jet. It was the platform for airlines to compete on service, comfort, and brand, and Boeing was printing money. The Trip 7 became Boeing's most profitable widebody program ever. Each jet sold at a premium. Maintenance revenues flowed for decades. Engine leases, parts, training, support contracts. The lifecycle economics were incredible. But here's the darker side of this success. Every Trip 7 sold made the 747 less relevant. Boeing's initial calculations were clear. The 747 was becoming a niche product. Only a handful of routes truly needed 500-seat capacity. Most airlines could fill a Trip 77-300ER more frequently with better load factors. So Boeing let the 747 slowly fade. Production slowed, orders dried up. The Queen of the Skies was being quietly dethroned by her twin-engine successor. Boeing cannibalized its own icon, but strategically it was the right move because if Boeing didn't do it, Airbus would. The Trip 7300ER racked up milestone after milestone. Tens of thousands of flights every single week, more than 1 billion passengers carried on this single variant alone. The 300ER became the face of modern long-haul aviation. The jet you'd see on every major international route. The jet pilots loved to fly. The jet passengers recognized instantly. This wasn't just Boeing's bestseller. This was the jet that reshaped global aviation. 30 years, over 1,770 aircraft delivered. More than 60 airlines operating them. The 777 isn't just a jet, it's infrastructure. The operational range is staggering. You'll see 777s on 16-hour ultra-long-haul marathons from Singapore to Los Angeles. And you'll see them on 40-minute hops between Tokyo and Osaka. That versatility is rare. Most jets are optimized for one mission profile: short haul, medium haul, long haul. The 777 does all three without breaking a sweat. Reliability became its hallmark. For airlines, that's gold. Every delay costs money. Every cancellation frustrates passengers. The 777 just works, but no aircraft is perfect. There have been incidents. The 777's accident rate per million flights remains one of the lowest in aviation history. That's not marketing. That's statistical fact. Airlines trust it. Passengers trust it. Regulators trust it. Boeing designed the 777 with a 30-year service life in mind. Many early jets are now being retired or converted. But here's the interesting part. They're not being scrapped. 777s are being converted into freighters. Even early 200 models are finding second lives hauling cargo for FedEx and UPS. That's a testament to the airframe's fundamental soundness. These jets were built to last. Over 60 nations operate 777s. That's cultural impact beyond economics. When a country's flag carrier flies a 777, it's a statement. We're connected, we're modern, we're global. For 3 decades, the 777 has been the gold standard, and it's still flying strong. Boeing didn't have the long-haul twin market to itself. Airbus was watching, and they had a different philosophy. In the 1990s, while Boeing bet everything on the 777, Airbus doubled down on 4 engines. The A340 launched with a simple marketing pitch: 4 engines for long haul. The argument was about safety perception. Passengers would feel safer with 4 engines. Airlines would have redundancy. ETOPS restrictions wouldn't matter. But the market didn't care about perception. It cared about economics. The A340 burned more fuel. It cost more to maintain. It required more thrust reversers, more tires, more of everything. And it offered no significant advantage over the 777 in range or capacity. Airlines started choosing the 777. The A340 struggled to compete. By the mid-2000s, it was clear 4-engine widebodies were dying. The 777 was winning. Airbus had to respond. It couldn't let Boeing dominate long-haul forever. So the company developed the A350, a clean-sheet twin-engine widebody designed specifically to challenge the 777. Airbus brought a carbon fiber composite fuselage, fuel-efficient Rolls-Royce engines, acquired a cabin, modern fly-by-wire systems. It was Airbus's answer to the 777-300ER, and it worked. Airlines that wanted the latest technology went with Airbus. Airlines frustrated by Boeing's 777X delays went with Airbus. By the 2010s, the battle lines were clear. 7 versus A350, twin versus twin, Boeing versus Airbus. But Boeing had another problem: internal competition. The 787 Dreamliner launched in 2011. A smaller, ultra-efficient widebody designed for point-to-point long-haul routes. It overlapped with some 777 models in capacity, but offered newer technology and better economics. Airlines faced the choice: buy more 7s or transition to 787s. Some chose the 787. United, American, ANA. They all bought large 787 fleets and began phasing out older 77s. Boeing was cannibalizing itself again, but this time it wasn't intentional. The 787's delays and production problems meant the 777 stayed in production far longer than Boeing originally planned, which turned out to be a blessing because airlines still needed 300 to 400 seat jets for high-density routes, and the 777-300ER fit that role perfectly. The market dynamic became clear for ultra-long lower-capacity routes, 787 or A350. For high-capacity long-haul trunk routes, 777-300ER or A350-1000. The A350-1000 became the 777's primary rival. Similar capacity, similar range, comparable economics. Airlines now had a real choice. Go with Boeing's proven workhorse or Airbus's newer tech. Fleet commonality started playing a bigger role. If you already operated Airbus, the A350 made sense. If you were a Boeing shop, the 777 was the easier fit. But the competitive landscape was shifting. Boeing couldn't just rely on the 7300ER forever. The jet was aging. The A350 was stealing market share. Boeing needed a response. They needed to prove the 777 legacy could evolve. Enter the 777X. Music. November 2013, Dubai Air Show. Boeing unveils the 777X program. Then it was the next chapter. The 777 reimagined for a new generation. Bigger, more efficient, more advanced. Boeing promised folding wingtips, the first ever on a commercial jet. Composite wings for weight savings. Massive GE9X engines. The largest jet engines ever built. A new cabin with better lighting, larger windows, more overhead space. 2 variants. The 777-9, capable for up to 426 passengers in a 2-class cabin with a range of 7,285 nautical miles. The 777-8, smaller capacity but longer range at 8,745 nautical miles. Later, Boeing added the 777XF, a cargo variant to replace the aging 777F. The launch customers lined up: Emirates, Qatar Airways, Lufthansa, Singapore Airlines, ANA, Cathay Pacific, Etihad. Every major long-haul carrier signed up except the Americans: United, American, and Delta. None of them ordered the 777X. Why? Fleet overlap. United and American were deep into 787 fleets. Delta was buying A350s. For U.S. carriers, the 777X didn't fill a gap. It was too much. But the Middle Eastern and Asian carriers saw it differently. Emirates needed an A380 replacement. Lufthansa needed a high-density widebody. The 77X made strategic sense if it delivered on time. It didn't. The first delays hit in 2020. Certification pushed back. The 737 MAX crashes weighed down Boeing. Its credibility tanked. Regulators started scrutinizing every new Boeing program with heightened skepticism. COVID-19 stopped aviation. Airlines deferred deliveries. The 777X suddenly looked like a jet for a market that didn't exist anymore. By 2025, the 7X still hadn't entered service. Test flights continue, certification drags on, and airlines are losing patience. Meanwhile, Airbus is delivering A350s by the dozen. Every delayed 777X is another A350 order for Airbus. Boeing's greatest success story is becoming its greatest test. The 777X has to succeed not just commercially, but symbolically, because if it fails, Boeing risks ceding long-haul dominance for good. The folding wingtips are brilliant engineering. The wingspan fully extended is 235 feet. Too wide for most airport gates, so the tips fold up on the ground, reducing the span to 212 feet. It's the first commercial jet with movable wingtips certified for flight. The GE9X engines are marvels, each producing 110,000 pounds of thrust. Quieter than the GE90, more fuel efficient. The fan diameter is 134 in, even wider than the GE90s. These are the most advanced jet engines ever built. The cabin is passenger-friendly. LED mood lighting, larger windows, higher ceiling, wider seats. It's what passengers expect in a modern widebody. But none of that matters if the jet doesn't get certified, if airlines don't trust it, if Airbus keeps stealing orders. The 777X is Boeing's bet that the 777 legacy still has room to grow, that there's still demand for a 400-seat jet in an era of fragmented travel. But the question lingers: has Boeing's greatest success story now become its greatest burden? While Boeing struggled with the 777X, Airbus didn't sit still. The A350-1000 launched as a direct 777-700ER competitor. Similar capacity bracket, similar range but newer technology, composite fuselage, quieter cabin, better fuel efficiency per seat mile, and it has been readily available. No certification drama. Airlines could order it and receive it. Qatar Airways became the A350's biggest champion. They took delivery of dozens and dozens, showcased them on flagship routes, built their marketing around the world's best business class on the world's best aircraft. Other airlines took notice. Cathay Pacific started buying A350s. Singapore Airlines did the same. Even Emirates ordered A350s for the first time. The market was shifting. Boeing's delays gave Airbus a massive opportunity, and they seized it. Every month the 777X certification dragged on was another month Airbus could pitch the A350-1000. Airlines started doing the math. Do we wait for an unproven 777X, or do we buy A350s that are flying right now? For many, the answer was clear. Go with Airbus. Fleet orders shifted. Qatar increased A350 orders. TAF did the same. Even Lufthansa, a 777X launch customer, started hedging with A350s. This is the nightmare scenario for Boeing. The 777 built Boeing's long-haul dominance over 3 decades. The A350 threatens to undo it in less than 10 years. But here's the nuance. The A350 isn't necessarily better. It's newer. And in aviation, new often wins, even if the difference is marginal. The 7300ER still outperforms the A350-1000 on certain metrics. More seats, more cargo, better takeoff performance, but the A350 has the narrative. Composite fuselage, quieter engines, modern cockpit, the perception of being the next generation, and perception matters. Airlines want to tell passengers they're flying the newest, most advanced jet. The A350 gives them that story. The 777X was supposed to reclaim that narrative, but the delays have cost Boeing dearly. Airbus capitalized on Boeing's credibility crisis. The 737 MAX crashes created doubt. Airlines started asking, can we trust Boeing's certification process? Can we trust their timelines? The A350 became the safer bet. Not safer in terms of actual safety, but safer in terms of business risk. If you order A350s, you know what you're getting. If you order 77Xs, you're gambling on when they'll actually arrive. For airline CEOs managing billion-dollar fleet plans, certainty beats performance. So the orders flowed to Airbus, and Boeing watched its wide-body dominance erode. The 777X must succeed, not just technically, but commercially, because if it doesn't, Boeing risks losing the twin market. It built with the original 777, 3 decades of dominance, 1 delayed program, and suddenly everything is at risk. The stakes couldn't be higher. Step back from the engineering and the competition. Look at what the 777 actually did. It transformed global aviation infrastructure. Boeing's Everett factory in Washington State, the largest building by volume in the world, ran on the 747 and then on 777 production. Thousands of jobs. Tens of thousands of indirect jobs in the supply chain. For the U.S. economy, the 777 is a massive export. At list prices, each aircraft sells for around $300 million. Multiply that by over 1,770 deliveries. Round it up. That's over $530 billion in export value over 3 decades, but the impact goes beyond dollars. Airlines built entire business models around the 777. Emirates wouldn't be a global giant without it. Dubai wouldn't be a mega hub without 777s connecting 6 continents. The 777 enabled the hub and spoke model to evolve. Airlines could consolidate traffic through major hubs and fly long haul with efficient twins. That changed route planning. That changed ticket pricing. That changed how we travel. For pilots, the 777 set a new standard. Fly-by-wire made it easier to handle. Thousands of pilots built their careers around 777 type ratings. For passengers, the 777 raised expectations. Wide cabins became normal. Quiet engines became expected. Reliable arrivals became the baseline. The 777's economics allowed airlines to lower fares. More people could afford to fly internationally. That's cultural impact. Families connecting across oceans, students studying abroad, businesses expanding globally. The 777 enabled globalization in a very literal sense. It also changed design philosophy across the industry. The 777's digital design process using CATIA became the standard. Every modern jet, Boeing, Airbus, Embraer, Bombardier, is designed in 3D CAD first. The 777 proved that virtual prototyping works, that you can eliminate physical mock-ups and still build a perfect jet. That approach saved time, saved money, and enabled faster innovation. ETOPS certification changed because of the 777. Regulators saw that twins could be just as reliable as four-reen jets. That opened the door for the 787, A350, and every modern twin. The 777 didn't just change one aircraft program, it changed how the entire industry operates. The 777 shaped the industry's DNA. And it's not done. 777s will be flying for another 20 years. Many early aircraft are being converted into freighters and will operate into the 2040s. That's a 50-year operational lifespan, 2 generations of pilots, 3 generations of passengers. The 777 isn't just an aircraft, it's infrastructure, it's legacy, it's the backbone of how the world stays connected. Let's talk numbers. 11,664 nautical miles. Hong Kong to London, the long way over the Pacific, over North America, 22 hours and 42 minutes in the air. 2005, a 777-200LR, the longest non-stop commercial flight by distance ever recorded. Doha to Oakland, Singapore to Los Angeles. Routes that define ultra-long haul, made possible by the 777, 40 minutes. Tokyo, Haneda to Osaka, Italy, all Nippon Airways. A 500-seat widebody, shorter than most people's commute. Same jet, opposite extreme. Over 170 aircraft delivered. An estimated 1.6 billion passengers carried. That is a staggering number, equivalent to flying nearly 20% of the world's population. Though many have flown multiple times, pilot stories are legendary. Captains talk about the 777's handling with reverence, smooth, responsive, predictable. It's the jet pilots want to fly. Passengers have their own stories. Proposals at 40,000 feet. Babies born mid-flight. Strangers becoming friends over 16-hour journeys. The 777 isn't just a machine. It's where life happens. Nothing lasts forever. Not even the 777. Early 77s are being retired. Airlines like United and British Airways have started phasing out their oldest jets. Some are converted to freighters. Others are parked in desert boneyards, waiting for parts to be harvested. As 787s and A350s enter fleets, older 777s are being replaced. The economic shift. Newer jets burn less fuel. They require less maintenance. They offer better passenger experience. For airlines, it's just business. Out with the old, in with the new. But there's emotion here too. Pilots who spent their entire careers flying 777s are watching their jets disappear. Passengers who flew hundreds of segments on 777s are seeing them vanish from route schedules. The 777-300ER is still going strong. Boeing's focus is shifting to the 777X and 787. The Classic 7 is entering its twilight years. But here's the thing. The legacy isn't fading. It's solidifying. The 777 did what the 747 did a generation earlier. It defined an era. It set the standard. It became iconic. If the 747 made flying glamorous, the 777 made it normal. It made long haul accessible. It made global travel routine. There is a beauty in that. The 777 wasn't about spectacle. It was about reliability. About getting the job done, about connecting the world without trauma. That's legacy. 30 years from now, aviation historians will look back at the 777 the way we look at the DC-3 or the 707, a jet that changed everything. It killed the tri-jet era. It validated ETOPS. It proved twins could dominate long haul. It made Boeing's fortune. It enabled Emirates' rise. It connected continents. And it did it all quietly. No supersonic speed, no double-decker drama. Just 2 engines, a wide cabin, and impeccable reliability. And for 3 decades, it did exactly that. But the jets will keep flying for another 20 years, another 30 years. The 777 will be in the skies long after most of us have forgotten what a big deal it was. That's a mark of great design. October 1990, Boeing made a bet. They believed that 2 engines were enough that twins could cross oceans, that airlines would trust the jet without the redundancy of a tri-jet or the capacity of a 747. It was a massive gamble. Billions in development costs. Boeing's reputation on the line, the future of long-haul aviation at stake. 35 years later, we know how it turned out. The 777 didn't just succeed, it dominated. It became the backbone of global air travel. It reshaped route networks. It enabled hub strategies. It connected cultures. The 777 wasn't just a response to airline needs. It shaped what airlines could do. The entire Gulf carrier strategy depends on efficient wide bodies. The 777 made that possible. Asia-Pacific connectivity boomed because of the 777. Transatlantic competition intensified because the 777 made frequency viable. Airlines could fly 3 777s a day instead of 747. More options for passengers. That's impact beyond aviation. That's economic transformation. For pilots, the 777 set a new standard. For passengers, the 777 raised expectations. For Boeing, the 777 was salvation, the last true Boeing aircraft. Now, the 777X represents the next chapter. If it succeeds, the 777 legacy continues for another generation. If it struggles, the 777's dominance becomes a historical footnote as Airbus takes over. But regardless of what happens next, nothing can erase what the 777 already accomplished. The Boeing 777 changed aviation forever. The Queen of the Skies may have been glamorous, but the 777, it made the world smaller. And that roar, the unmistakable thunder of a GE90 spooling up, will echo for generations. This is the Boeing 777, the twin that changed everything. Hey, before you go, the YouTube algorithm thinks you're going to like this video next, so why not check it out?